Very happy to be part of the conference. Thank you very much for the organizers to have me here. And I am going to share some of my experiences in my past 5-6 years with you in applying AI in this world. And first, I'm sure most of the people don't know me, so I start with a brief introduction of myself. And it's a little hard to do this kind of talk in remote situation, but please be free to ask any questions. If I have some time left at the end, I will try to answer live. This is a live, non-recorded session, as you can see, so anything can happen. But if I go over time and don't have enough time for answering questions, I try my best to answer in the chat. So just looking back briefly at my career here as a way of introduction, I was a particle physicist, like many of you here, maybe, doing data analysis of the Atlas experiment at LHC CERN, which I enjoyed tremendously, as my passion has always been in data and analytics, starting from my time in university and later as a researcher. And I made a switch to business through the power of Boston Consulting Group, who were willing to hire people with background like mine. And that was a very good opening door for me to get into the business world and get to know a lot about how businesses work and how my data and analytics capabilities could be applied to the variety of field of businesses, which I will go over today as well. I also call myself an entrepreneur. I started my own company called Shiroyagi back in 2013 and served there for about 3 years as a CEO before joining DataRobot as a data scientist to start with, and became a chief data scientist and later CEO of the entire region. So much of my talk today will be based on my experience and my observation through this time in the last 5-6 years, which was one of the most exciting time for AI. As you all know, the technology had made a lot of advances, and a lot of companies have expressed strong interest, especially in Japan, in applying this technology to their business. And looking back at my career, my career journey has been one that changed my perspective of data a lot. In particle physics, people used to say that finding discovery is like finding needle in the haystack of data. And quite a contrary to it, in business, I met many people that believes that the more data, the better. So it used to be that my job was how I can throw away most of the data in the first 1 second of the data taking, just so that there was enough disk space to save the important part of the data. Whereas in business, many people just simply believes that the more data they have, the better. Data is like oil. And that's where I felt somewhat of a gap, and also found opportunities for me to add value in finding value in data using the power of algorithm and approaches to data. So hopefully the story I will share will be enlightening to some of you who might believe just having more data is always good, which is not always the case. And what you can do with it is more of an issue. How you can do it, especially as well, is very much a big question. So the goals of this talk, which has this weird title, which I gave some months ago, and now I had to think somewhat to make it worthwhile. And 3 points that I want to go over today. One is I want to share through my observation and the experiences the structure of ever expanding potential of AI, which hopefully many of you believe in here, and how data and algorithms can reshape existing industries. I will go deeply into this today. And one of the aspects that I want to bring in the geography part, which is Japan, where I served as a business leader, expanding the potential of the data and AI itself, as well as how to be successful in developing AI business in Japan. So if you are in this business, if you are interested in going into other markets, maybe Japan, this is where I might be able to shed some light on giving you some hints and some partial answers to how you can best strategize and operationalize your data AI business. So I do want to talk a little bit about DataRobot, which was a company I spent some time with, and I was very much surprised to see their product when I joined. And in case you don't know, it is an automation software that automates a lot of what used to be done or is still done by data scientists with a lot of difficulties and time spent, and really giving it the technology, the power to be applied everywhere and by anyone. That might be a little bit of a stretch if I said anyone, but really it had this interface which was graphically driven and made it so much easier for anybody who's interested in applying their data, their own data, in their own business. So it had a capability of machine learning, which was the highlight of this platform, and it had a capability of building models using the latest machine learning algorithms, starting from deep learning, of course, but also a lot of traditional tree algorithms and regression algorithms, and all those things can be run with a click of a button. And I felt really this will shape the way we look at data, the way we use data. It seemed so powerful when I saw it at first, and I was right in that, as I found a lot of new use cases that I found through the journey of making DataRobot successful. And it's hard to talk without knowing where you come from and what level of technicality you are, but through the recent decade of experiences, the understanding in the structure of processes in deploying data and AI-driven decision making or application that are built based on it has been well established, I'd say. The variety of data that you can feed into that process, as well as the types of problems that you can solve using this approach, has expanded significantly during that time. And roughly speaking, as I'm showing here, what's in between the complex process, which I'm saying a lot of which is automated with the power of new software platforms, can be broken down into data preparation, which can itself be a big industry and time spent, as well as some of the more glamorous part of analytics, which is the recent advances of machine learning and automating how to run machine learning training and prediction. And also, it is more recently becoming more of an issue to how to know and have the capability of maintaining the applications that have been built and running them continuously, and also updating the models continuously to keep them in such states that it is fit for being part of the mission critical business operations, and the variety of business values that that you look to has really expanded as well. Of course, oftentimes it is about increasing the top line. Oftentimes it is about reducing the cost of operation, or oftentimes it's risk mitigation, or just building brand new service that has the intelligent capabilities within. Sorry about that. So my big question was, how much can data and AI reshape the existing industries? It is clear, and I believe very strongly, that there are a lot of opportunities and possibilities, and that comes from my experience as a data scientist in academia, as well as seeing a lot of successes of companies using AI for the internet, most primarily Google, or any of the social networking service like Facebook and TikTok. And they have seen a tremendous success applying data and AI in their business. And as I said, my primary interest with DataRobot, and in this talk in particular, is how you can apply AI in the existing industries, which there are many, especially in a big economy like Japan, the biggest one being manufacturing, as well as retail, telecom, financial. All those wide-ranging industries existed and showed a lot of interest in how they can incorporate data-driven approaches. And of course, I'm also very heavily interested in application of AI in other beautiful things, as I'm calling it here, like art and sports, and I'm particularly inspired to see the Olympics and how data has changed their performance and so on, which is always a fun topic to talk about, which I will not go into much today. And bringing in this geography aspect, because it makes it interesting um, for this talk, is why Japan? And Japan has been early in entering strategizing data and AI. They had come up with this national strategy for artificial intelligence technology back in 2017, and you got used to seeing a lot of countries doing this sort of thing, but Japan was one of the first one, only second to Canada, apparently, with a big title of Society 5.0, whatever it means. And what's important is what's in the background of it. Japan, as many of you know, has a big economy. It is still the third largest, about a third of United States. This is estimated for 2021. And if for whatever reason you are afraid of going into China, it would automatically become the second largest market for your business, which it was the case for DataRobot. They were quite hesitant to go into this market for good reasons, and that's why Japan was one of the important regions, as with many other companies. And what's driving one of the concerns and the demand for AI is the aging and shrinking population in this country, which is well supported by data. It is the most aging society as of now, as well as what's projected for 2050. And of course, many countries have this problem, or will have this problem more, although Japan is a front runner in it as well. It is well perceived as a problem in Japan. It's a little bit small chart I'm showing in the right hand side in the middle in green is that Japanese people seem to think 87% of the people thinks this is a big problem, and that's very clear in this study, as you can see. If you compare that with the US, which is ranking towards the bottom, is 3 times more people who are concerned about this situation, and the concern is very well justified for how to support these people, how to support the economy with shrinking population who are fit enough to work. And Japan, the other thing that makes it interesting for Japan is it's a little qualitative, but I saw a lot of companies very willing to try out to start their journey in AI and data. And little companies really takes it very far on convenience, robustness. In Japan, trains are almost never late. They run very fast as well as very never late. And if you go to any retail stores, you see wall full of products. As you can see in the middle picture is what you can see in every convenience store in a corner of every town. And they do very well, as well as the level of convenience that they sought after is very high. So in terms of people, they're very much strongly interested in how they can solve their problems or replace what's been done by humans and automated and being more efficient at providing this level of robustness. On the flip side is a study that you may have seen, or a similar version of it. This particular one was done in 2016 by the Obama administration, looking at the papers with at least one citations on AI, or more specifically deep learning here. And maybe people produce these papers like how they fake Amazon reviews. I don't know. But I'm less interested in China versus US here, which was probably the primary purpose this report was trying to illustrate. But if you look at the ranking below, Japan ranks pretty low considering how they have been in advantage for technology. They're considered a late follower in AI, and in this chart, or in this way of counting, it ranks not even the 5th place. And this is one of the points that I wanted to make, is given the national interest in leveraging AI, the AI expertise and technologies needed to realize those national and corporate AI strategies, as well as maintaining that social robustness that I pointed out, is and will be critically lacking. And this is not a unique situation that expertise and resources lacking. It is the case everywhere, but it is very clearly the case for this part of the world. So I want to talk a little more deeply into what people are doing, and also more into the potentials of what you can do in this market in terms of use cases. And also I will point out some of the technical challenges that I had learned through my journey. This one is a public use case that I took part in at the time I was at DataRobot. And one of the hotspots that we found in this market was demand forecasting. And as I pointed out, Japanese retailers are known to densely pack their small stores with typically more than 2,000 types of products in a small store. And this is an example of reducing the time it takes to determine their next ordering and minimize the waste inventory. So with the help of AutoML, these were not data scientists who worked on this use case to build a model. It were more business analysts, and they built predictive models based on time series product level sales data. That is to say, which product sold in what quantity in which date, in order to improve the accuracy of inventory. And this was also timely because they applied this to food stuff that expires faster than some of the other things, and the demand forecasting for such goods is more critical because after 2-3 days, and if you got this inventory wrong, your food is going to go into waste. So reducing food loss has been a socially well-watched issue, and they were able to not only say that the advances they have made in applying AI, as well as how they are doing good socially. And this type of approach is now under development by most of the major retailers in Japan. In the case of Lawson, which is one of the 3 largest nationwide convenience store chain, they have already rolled this out to 15,000 stores, and the trend is very much a big one in the industry. And I was very surprised to understand that demand forecasting by itself has a lot of opportunities to be applied into a variety of various aspects of their businesses throughout the value chain. Demand forecasting for production, how many to produce, demand forecasting for sales, which part of the sales needs boosting, or sales planning as it is, as well as how many things to be delivered. And there's a lot of aspects of optimization that can be done at the next level accuracy with the help of AI. And also some of the more interesting, if you look at less of the retail, but consumer goods side, there are already a running example of AI being used in R&D, like product development. And there was one public use case by Lion, which used AI in designing the toothbrush. And that sounds like a weird use case at first, but what they did was, apparently there's some standard that they have to conform with any product they produce, and they were predicting how the design parameters will fall within or without that regulations when made into a product. Looking at another example, this is not DataRobot, this is actually done partly by a company called Tractable, which is a UK based AI company, and they had also shared the same experience as I, which is that Japan was surprisingly a fast-growing market for their business, and one of the biggest as of now, though they do expect other markets will follow and exceed in business side. But this was interesting to me because it coincided with my experiences that the Japan market growth was much faster than many of the others combined. So this case was a use case in insurance, in particular P&C and car insurance, more commonly known. And they use predictive model to assess auto damage. So if you are in an accident, and if you're like me, you might go into accident somewhat frequently, and you need help from insurance company in fixing your car, paying for fixing your car. What happens is that you take your broken car to the garage, and they make a quote which may be reasonable and may not be reasonable. So the insurance company have this process of appraisal, which is validating the amount claimed by the garage to fix that damage is reasonable or not. So the problem here, which is also interesting in the context, is that the appraisal team of insurance companies, almost all insurance companies, are very quickly approaching retirement age. And I was like, why don't you hire more people in the team? And they are not doing that. They have been seeing the accidents being lower and lower every year. And also they do expect that automated driving cars will come into the market pretty quickly. So they are not hiring new people into this team, and instead they chose to automate a lot of this process. In this case, they saw this appraisal process reduce in time by half with the help of AI estimating what is the right amount for the quoted damage by using the images that were taken by the users. And this solution is being embraced by most of the top insurance, the P&C insurance companies in this market, as well as they were able to expand their market outside of Japan with the same solution. So insurance was not a new entrant to using data. They have been data driven in many parts of their business from long before. Maybe some of you are actuaries here. They have this qualification for not exactly data science, but knowing statistics and knowing how to draw conclusions from data. So they had always been using models to develop their product, which is to say that they predict risks and develop pricing strategy for how much they would insure for whatever cause. Although this is subject to regulations depending on countries. In the case of Japan, life insurance do not have much freedom in changing this pricing for the benefits of fairness to the consumers, but in PNC they have more flexibility. Some of the other things are common to many industries, but the sales, like for example, if you're taking car insurance, you probably have an experience of being suggested for adding additional options that they will charge more for, but if they know what sort of thing you're sensitive to, they can upsell a given deal, as well as they use models to cross-sell existing customers with other types of insurances. And it is always a case of maintaining those customers in this industry with a lot of competitors. So they use machine learning to calculate the likelihood of customers churning and take sort of focus sales reps activities to minimize potential cancellations. And more activities specific to insurance are subject to benefit of AI as well, such as underwriting, which is deciding which customers to approve for a certain plan. And this can become very technical. In the case of life insurance, it involves doctors and those specialists. Appraisal is the case that I have talked about just earlier, in the fraud detection, which is to say that sometimes people claim that their car is broken even though it isn't, or any of such fraudulent claims are investigated, but not all. So they want to focus their attention to the claims that have high likelihood of fraud. So again, there's a lot of places, as I found, and as you may be aware already, of applying AI throughout the value chain. And the final example is infrastructure and manufacturing, which is the biggest industry in Japan. And it is not just the non-Japan companies doing AI in Japan. There are companies, most of the companies are about how to build their own in-house capabilities of data science. And recently I talked in my podcast with the leader of this data science team in Japan Rail, who organized, as he was building this team, one of the things he did was to organize a Kaggle-like public competition in a service called Signate, which is a sort of Japanese version of Kaggle. And it was very interesting. What he found was that there were obviously a lot of external data scientists competing in there as well, but who came in first rank was actually an employee in their very company, and who was a bullet train driver. And it was a very big surprise for them. But they realized that there were a lot of people already existing internally in working in a capacity of data scientist or such like. And that's how they were successful in building an initial team of data scientists in this Japan Rail. This is the Western Japan Rail. And this particular use case, which is also written by the Nikkei newspaper, so it's public, is predicting failures of ticketing machines. The question is how long more are we going to use physical tickets? But anyway, there are hundreds of ticketing machines within their region, and those machines break. These machines are very sophisticated, and I read that these machines turns around the tickets so that it will come up always from facing and so on. And there's a team of people who are maintaining these machines, but knowing which ones are more likely to break down allows them to prioritize maintenance work. And they were actually, with this example, with this use case, able to achieve the same level of maintenance with about 40% less manpower. So it's very successful as well as interesting in how it came about. And also, they are this railroad company, but this became a one of their products, and they started selling this solution to other railroad companies as well. So a lot of interesting successes. And finally, I talk a little bit more about manufacturing, which in this case includes the example that I just talked about. But manufacturing very much is the biggest and one of the more advanced area of industries in Japan. And again, my point is the same in that it has very significant AI use cases throughout their value chain. One of the ones that I'm particularly interested in is called materials informatics. And this is where if you're a chemical company, for example, and you're trying to come up with a new material with exotic properties, like maybe it is very light and very strong, or it would not burn although being very light or such, what you do is you come up with different ideas and you run experiments to see if that new material has that property. This is a very time consuming process, and one that can be assisted by AI by building models of, if you tried with this material, what would be the property of it if you had done the experiment. So the point being is that you can speed out the material search process very much. And this is an approach that is also being experimented by the pharmaceutical companies in speeding up drug discovery as well. And coming from academic background, automating some of the discovery process is one that's very interesting as well as very valuable for the human being as a whole, let's say. And of course, there are use cases in production, which is all about quality. How can you optimize the production process and the parameters that are within the process to achieve higher quality? Or if you are not achieving higher quality, you might as well know that earlier in the process so that you can alter the process for a better result and improve the yield, which is particularly the case in industries like semiconductor, where the yield, especially at the beginning of the production, tends to be very, very low. Sales and marketing, especially in B2B, there will be which company to target for particular type of product, scoring leads, like contacts that they get in the events to determine the priorities of potential customers for the salespeople to visit. And once the product is released to the customer, there are use cases like the one that I just talked about in failure prediction, optimizing the maintenance, as well as which parts to have in the inventory so that you will be able to provide the part for service in a timely fashion. I'm going to touch upon some technical traps as I have observed, and this is not no way an exhaustive list of any, but there are of course gap in expectations that people have between what people think AI can do, and there is some of it is just plain stupidity, but oftentimes it is more subtle, and it was surprising to me as well. And if I name some of those things, I think a lot of technical challenges come from the fact that the machine learning is not good at extrapolating. And for example, a lot of I think you can millions on this if you solve these problems, but predicting sales of non-existing product, new product, you're developing a new product and you want to predict the sales of this new product. This is, I would call this a holy grail, because this will be a money-making machine. But one, there is not really good valid data for training machine learning on this topic, as well as machine learning in general is not good at telling what will happen under the situation that it has never observed, or situation that doesn't really associate very well to what has been seen before. And same is the problem with anomaly detection. Anomaly detection by its own definition is detecting what you have never seen. So I have been part of a lot of such anomaly detection projects, but it's very, not only it's difficult to build models, building model might be the easiest part, but it is hard to build models that are sensitive to the type of anomalies that they want to be sensitive to, or even verify the accuracy of the sensitivity can become a big question as well. And again, related to that is new compound material search, which I just talked about as having a lot of potential. But as of now, it is still, I would call, experimental stage, because it is limited by the same aspect of machine learning, which is that the data you have is what you have done before, and what the machine learning learns is the past patterns that has been observed in this data. So there are different there are techniques that are proposed to expand on this, such as active learning, which is to indicate what type of experiment can increase the knowledge than others, and being optimal at doing this time-consuming experiments to best speed up that search process. But this is not very well established, I would say, or hard to operationalize type of process that I have not seen many companies comfortably do as yet. One of the other aspects of technical challenges is the one in the middle, and titled translating into action. So as I said, demand forecasting in particular in retail or CPG, it's very widely applicable. One problem is that such models were badly broken by COVID, because consumer behaviors changed very significantly. But that's not the main point that I wanted to make. Often the forecasting has forecasting less. So for example, if you say there will be this many calls at the call center, forecasting more means you will have excess people answering calls, which means more cost. Focusing less means that you're not answering calls. So it is more problematic. So there's an imbalance in the implications of predicting more versus less. And as you know, there's always more or less. There's only statistical models at the end of the day, and it makes it difficult to determine the actions to be derived from these models. And finally, the point that I wanted to raise in the technical traps is the causality and inference. And everybody knows causality and correlation is sadly different. And it is a talk in town that how AI can explain itself on the decisions that it is making. But even this is not causality at all. It is only explaining this is the reason that it is outputting this prediction, but doesn't mean that uh, if you change the inputs, the prediction will be affected as expected. So you might see one of the leading feature is a variable like person's age, but oftentimes you cannot control person's age, or even if you can, it doesn't mean that the change that you will observe in that system is what you would expect based on the model output. And this is, again, a big question that you can make millions on if you solve is marketing mix model. A lot of companies want to know how best they can distribute their marketing spend to maximize the effect, which is selling more goods. But very often this type of model makes dissatisfied conclusions, such as they are spending a lot of money on TV advert, but the model says it actually has a negative impact, meaning the more TV advert, less product will be sold, which is not an acceptable conclusion. But this is a kind of use case that is very hard to get unless there is a very deep human intervention in the process of modeling. So those challenges aside, I hope I convince you somewhat that there is a strong motivations by the country as a whole and those companies. And there are a lot of great companies in Japan. And from the business perspective, there are tons of great logos to be won. And if you identify the right opportunities and the business models around you, and Japan, in a way, you can say is an ideal test ground because it is facing problems before other people outside Japan. And the momentum is definitely there to start and develop their capabilities and applying data and AI in their business. So that's why that explains what I had experienced, which was Japan was a faster growing market than rest of Asia and Europe combined. And this was observed by some of the other companies that I have heard stories from. So now I am going to go into the final part of my talk. Hopefully I'm doing okay with time or not. Yeah, so I think I'm almost over with my time. So yeah, I'm going to be very quick actually. But one final point that I wanted to make is that there is definitely big demand by company, and there are many ways that you can strategize building a business in Japan, starting from you as an individual going to work for them, which is a valid approach. But if you want some more leverage in terms of business, uh, probably the biggest talk in town is how you can build products that is very scalable and localize it to the market like Japan. Japan is a very language sensitive country. Everybody loves to use Japanese language. So that aspect of work is definitely needed. But just one aspect, finally, I am going to point out is Japan IT talent, including data scientists, are very heavily in the side of IT companies, IT services companies versus user companies. User companies are companies that are in the traditional business, manufacturing, retail, and so on. But most of the IT talent actually is in those IT companies that specialize in IT, which is a very big difference, as you can see here in comparison with the US. It is a completely opposite situation. So if you're if you have a product or are going to develop a product and really looking to sell that big time in Japan, the partnership you build with these companies is going to be critical. And there are many good and huge IT services companies that are looking for such products to sell for themselves as well. building such partnership is tricky in many ways. Big ones are not always the right one. You'd want to identify the right partner. You want to build the right business model, including what margin to give them. If you give them 40% or such, they will definitely be going very strong after their customers. And that's very much secret to success, is how you can harness their sales capabilities and to your advantages. So sorry, I was a little bit rushing towards the end, but I hope I gave you some perspectives on how AI can be an exciting business in Japan. And if you're interested in knowing more, I'd be happy to answer questions and happy to help.